Now let's take a look at one of the most powerful processors in Ozone, the Dynamics module. This module is another multi-band module and is capable of compression, limiting and expansion of any of the bands. First, a quick overview of the interface. At the top is a spectrum display area. This can be switched between three views. Crossover view, where we can see how the bands are laid out. Gain reduction trace, for a visual view of processing in real time. And detection filter view, for setting up the detection filters. It can also, like many of the other modules, operate in both stereo and mid-side mode. We've looked at the various modes elsewhere. Beneath the spectrum display area are the controls. This can either be a detailed view of one band's controls with comprehensive band metering, or a combined view of all bands' controls. Switch between bands or the all bands view using the icons towards the top right of the control display. Alternatively, click in the spectrum view band region that you wish to adjust. Note that in single band mode, the controls change colour to indicate which band is currently being adjusted. Just beneath those icons is the link switch. When this is lit, all controls are linked to each other, so for example, adjusting the threshold on one band adjusts the threshold on all bands. This is a relative control. If, for example, you drop the threshold on band 1, then click on the link button and adjust the threshold on band 2, band 1's threshold will be lower than all the other bands. As with other multiband processors, a band can be added or removed using either the plus and minus icons in the bottom left-hand corner of the display area, or right-clicking in the spectrum display itself and using the context menu. Each band can also have any processing bypassed using the on-off switch, or soloed using the solo icon. Crossover points can be adjusted by click-dragging on the vertical lines that indicate those points. Similar to the exciter we looked at earlier, this also has a learn function to set optimum crossover point. Start playback and click on learn to activate that function. After a short time, the crossover points will be set to suitable points for the material. Now we've had a quick overview, let's take a closer look at it in use. We'll start with a single band display and setting up the detection mode. There are three choices chosen by clicking on the relative option found at the bottom of the meters. First is peak mode. The detection circuit is looking at peak levels of the signal, useful for levelling out sudden peaks. RMS is useful when trying to change overall level without affecting the character of the audio and is responding to average levels of it. It tends to respond slower than peak mode. Envelope mode is very similar to RMS, but envelope mode evens out levels across all frequencies, but without artifacts or aliasing that RMS detection can cause. Detection filter view allows us to set up a specific frequency response, particularly useful if using the module in single band mode. There are three modes. None means that no filter is used, and detection is equally sensitive across all frequencies. High pass sets up a high pass filter. This can be click-drag to adjust frequency, and the steepness of the slope can be changed by changing the slope setting. Choose from 6, 12, 24 or 48 decibels per octave. Tilt provides a curve weighted towards the higher frequencies. The slope can be adjusted further using the amount parameter. Use the solo button to isolate the filtered frequency being used to trigger the module. The gain reduction trace view is very helpful when setting up the module, giving a visual representation of how the module's working and applying gain reduction. The threshold is a multifunction display. As well as providing metering for any incoming audio, it also indicates any gain reduction that may be applied by either the compressor or limiter, using red meters that come down from the top of the meter. At the bottom are green meters that indicate any expansion that's being applied. On the left is the limiter threshold setting. Use this to set the trigger lever for the limiting section of the module. Limiting is similar to compression but applies a much harder gain reduction, the idea being to limit the signal that's overshooting the threshold rather than just compressing it. On the right is the compressor's threshold setting. This is the point at which the compressor is triggered either for gain reduction if compressing material, or the point that expansion stops if expanding. Remember, compression is gain reduction applied to signals that go over the set threshold. Expansion is gain increase to signals below the threshold. Both the limiter section and compression section have identical controls, and both can be used in a very similar way. The limiter can be set up to compress, and the compressor set up to limit. The only limitation is that the threshold for the compressor must be set equal to or lower than the limiter. The main differences between compression and limiting are the ratio used in attack times. High ratios of 10:1 or more are usually associated with limiting, while lower ratios are compressing. The ratio control is used to set that. Both of these are capable of being set to negative ratios, which then changes the function of the sections into expanders. That increases the level of the quieter material below the relevant threshold settings. Limiters usually use faster attack times. This is how long the processor waits before applying gain reduction. The idea being that overshooting signals are processed as fast as possible. Both limiter and compressor are able to have their attack time set between 0 and 500 milliseconds. Release time is how long the processor waits once a signal has dropped below the input signal before releasing the gain reduction applied. Very short release times can distort low frequencies or cause audible clicks. Slightly longer but still relatively short release times can cause pumping, which is desirable in some genres such as dance music. There is an adaptive release switch that is on when lit. It automatically adjusts release time based on signal peaks. If a transient peak is detected, the release time is scaled to be shorter, whereas if a sustained note is detected, the release is scaled longer to avoid distortion. This scaling is in relation to the release signals set by the release controls. The knee parameter controls how the gain reduction is applied. Low settings result in a harder knee, meaning that gain reduction is applied at or above a short range close to the threshold point. Higher settings result in a softer knee. This means that the gain reduction is applied over a greater range, starting below the threshold and extending past it. The parallel fader controls the dry-wet mix of the signal and can be used to set up parallel processing. Beneath that is a dynamic curve meter, which provides visual feedback of threshold settings, dynamic curve, and gain adjustments. There's a node for the limiter and compressor, which are linked to the relevant threshold and ratio controls. These can be click-dragged to provide an alternative visual way to set up the controls. Finally, to the right is the gain control for adjusting the makeup gain after processing. Click on the Auto Gain Compensation button to automatically adjust audio levels comparable to the unprocessed signal. This minimises gain changes, which is helpful when embedding various settings. Now let's take a very brief look at the all-band view we saw earlier. In this view, all 4 band controls are visible at once. To adjust parameters, either click-drag up and down or double-click over the parameter text view for manual text entry. There is still some metering for each band levels, compression and expansion, but no graphical dynamic curve view. And that's Ozone's Dynamics module, a fully featured, all-in-one compressor, expander and limiter.